Hey guys, what's up? It's Caleb here, and we're going to be talking about the char data type. This is categorized in the integral data types, and you'll see why in just a minute. So the two main purposes of the char data type is to store small numbers or characters. Definitely a useful data type that you need to know about, so stick with this video, it's going to be a lot of fun. You know what else is fun? Building awesome applications. And you know how you can do that? You can do that with Embarcadero's C++ Builder. C++ Builder is an IDE, and there is a community edition, so you can get it completely for free. Go check out their website because they're going to have every tool you need to build C++ applications and deploy to multiple platforms. So with C++ Builder, you can deploy to Windows, Mac OS, iOS, and Android. And some of the tools that come with the program include an awesome debugger, a visual UI developer, so drag and drop elements, built-in access to popular databases, some more cool modern technology like Bluetooth and IoT capabilities, and lots more. Overall, it's a great application if you're looking to do some serious C++ development. I'll leave a link for you guys in the description. Be sure to check them out. All right, now I want to talk about the char data type. So the char data type can actually be used for two purposes. The first is store characters, and the second is store numbers. So we're going to talk about storing characters first. But first, compared to these other data types, if you guys remember from the previous video, I said a short was 16 bits. Well, a character is actually 8 bits. So if we're comparing size here, char is the smallest of them all. That means if you're going to be storing numbers, your maximum is pretty limited, and we'll get into that. But for now, let's get rid of these other data types and talk about how to store a character. So we can create a char variable like so, and then we can assign a character to it using single quotes. So you have to use single quotes. Double quotes are reserved for strings in C++, which is not the same thing. So for a char literal, we need to use single quotes, and then we can put any character in here that we would like. So for example, we could put capital A. Now to output that, very simple, we just see out X. And we run that, we get A. So overall, that's pretty simple. Now, how exactly is this stuff stored? Well, characters are actually stored in the same way as integers. The only thing that differs is the way we interpret them. So for example, we could interpret this X as an integer by casting it to an integer like so. So by putting those parentheses with the int before it, it's going to print it as if it was an integer. And when we do this, we get the value 65. And when you do this enough times, you start to associate numbers with letters. So capital A is 65. If we put a B, it's going to be 66. So how do you know the number equivalent for a character? Well, it's based off of something called the ASCII table. This is the ASCII table, and you can see it's a pretty overwhelming chart. So the things you need to worry about here is the DEC column, decimal, and the char column, which is in red. So for example, for the letter A, the capital A, that would be found right here. And you can see the A has a decimal value of 65. So if we convert an A character to an integer, we get 65. So it all really depends on how we interpret this stuff. This means we could, in theory, use the char data type to store numbers. So what if we did store a number in here? Well, going back to the interpretation thing, if we ended up putting something like 65 here, we're saying that we want to store the character with the value 65. So when we output it, we should still get A. And you can see we do. But obviously, if we're trying to store a number, we're going to want to output it as a number. So we might cast it like so, and we get the value 65. So you can see that works, but I am going to warn you guys of something. If you forget to do this cast, it can be a little bit confusing. For example, what if we put the value 55, and then we did not cast it to an integer? Well, now when we compile and run, we get a 7, which that's confusing. The reason we're getting a 7 is because 7 is the character with the ASCII value 55. You can see the 7 right there, 55. So what exactly is the maximum value here? Well, I'll tell you guys right now that the maximum value is 127. When we compile this and run, nothing bad happens. But if we put 128, watch what happens. You can see we're getting a warning, and when we look at the full picture, you can see what's happening is that we're getting an implicit conversion from int to char, and it changes the value from 128 to negative 128. What's going on? Well, this is known as overflow. So basically, when we put a number 1 bigger than the largest possibility, it goes down to the absolute lowest number, which is negative 128. So if we increase this and we did 129, when we compile now, it should go to negative 127. And you can see negative 127. So when we're storing numbers that are too large to fit in a data type, it's just going to wrap around, start at the very lowest number, and then continue counting up. So if we want to store a number in this, it looks like we're limited to 128 as the highest number. That is, assuming we're using a signed char. If you guys remember from the previous video, signed means it allows negative numbers. So we could actually put in here unsigned. And this is going to allow us to store a number such as 129. So when we compile, we don't get any issues. So this is going to allow us to store up to 255, which is a little bit better. So char by default, in our case, was signed. It's actually up to the compiler though. So if you want to be specific, you can even specify signed here. So there's signed char and unsigned char. Now when it comes to characters, you might see on this ASCII table, there is this extended ASCII codes. So you might think if you use an unsigned char, we open up all these different characters here. Yeah, in theory that'd be nice, but it doesn't quite work that way, because the extended ASCII codes is not standard with the normal ASCII table. There are actually numerous extended ASCII codes, so what happens is if you try to do one of these characters, it's just going to spit out a question mark to you. So for example, we can go in here, we're going to make this unsigned, like so, and then we're going to put this out as a character rather than an integer, and when we run, we don't get anything in the console. So if you're using a char for numbers, yes, you can go over 127, but if you're using it for characters, you definitely want to limit yourself to any of the standard characters that are in the ASCII table, right here. Now obviously, this is a lot of characters and can cover most of English, but English is not the only language out there. I know us Americans have a hard time of realizing that we're not the only people that exist in the world, but there's actually a lot of other languages out there, and with that, you're going to need something called Unicode. So if you're building an application where you need to support multiple countries or languages, then check out Unicode. I might get into that in an upcoming video, but if you just want to do a little bit of research on that right now, look up char16_t and char32_t. These are char data types that'll give you enough memory to store a lot more different possibilities with characters. So thank you guys for watching. Hopefully this was helpful and a good introduction to the char data type. Main thing you need to know is that it's primarily used to store characters, but with a little bit of perception, you can actually use it for numbers as well. Just make sure you're really clear with your intent. If you're trying to use it for numbers, you have to output it as a number with casting it to an int, like so. So that's all I got for you guys. Please be sure to check out the next video. I'm not sure what we're going to do yet, but it's going to be awesome. I think I might either go over the Unicode stuff, or we're going to be talking about the bool data type. So check it out guys, and if you've enjoyed the content, please consider subscribing.